So for this question, it says state the conditions for the function f to be continuous at x equals to c. So the point here is x equals to c. The first condition of continuity is coordinate. Coordinate of c must be defined. So is defined. Then condition number 2, limit for x approaches c for the function must be exists. So this is the continuity condition. And then condition number 3 is coordinate fc must be equals to limit where x approaches c for the function. Then we look at question B. We have a piecewise functions here. It say equals to 2, which is 3. Not equals to 2 means the function left and right here will be x squared minus 4 over x minus 2, x squared minus 4 over x minus 2. So discuss the continuity at this x equals to 2. So based on our rules of continuity condition, the first one, if you want to analyze at x equals to 2, means the function. So this function is not f. This function is denoted by qx. So you should be writing it as q2. Coordinate 2, we can observe very clearly, which is equals to 3. So condition number 1 here is defined. We have the coordinate. We managed to find out the coordinate, means the point is defined. Then number 2, we need to identify whether the limit, we need to evaluate the limit for x approaches 2 for the function. So when you want to approaches 2 for the function, you can see left and right, actually they are having the same function. Therefore, we no need to separate it. We can x approaches 2 directly using the same function here, which is x squared minus 4 over x minus 2. So no need to do left hand side and right hand side, because left hand side and right hand side, they are having the same function. If you separate, calculate it left hand side and right hand side, it will come back still the same answer. So to simplify, to evaluate this limit, you substitute, we get IDF. Therefore, we need factorization from this quadratic x minus 2, x plus 2, and this factor of IDF x minus 2 can be cancelled. Then we evaluate, we get 4. Then continue. The condition number 3. We can see the coordinate is 3, the limit is 4. So we can notice that coordinate 3 is not, coordinate for x equals to 2 is not same with the limit approaches 2 from the function. So this function should not be written as fx, it should be written as qx. Therefore, from here we can saying that qx, put out our conclusion, qx is not continuous at x equals to 2 because it cannot fulfill all 3 conditions here. Then when we move to the question C, we have a piecewise function. So when we're doing piecewise function, we need to draw up. We have 1, less than 1 function x. Between 1 and 4, function ax plus b. More than 4, function negative 2x. And you can see the equal sign is at here. So this point, the x equals to 1, it is follow x. And when you have x equals to 4 here, the x equals to 4, you can see it is follow the function negative 2x. Then you need to find out the value of a, b such that this function is always continuous on the interval from negative infinity to infinity. So when it is said that this interval is continuous, means this function supposed to be connected to this function, and this function supposed to be connected to this function for all the interval from negative infinity to infinity. So when we want to write out the continuity equation at x equals to 1 and x equals to 4 here, make sure we not only just writing limit left hand side equals to right hand side. Limit left hand side equals to right hand side, it just can show the limit axis. For continuity, you must show out the limit is axis, together it is same with the point. So therefore, at this x equals to 1, the limit for x approaches 1 from the left hand side, which is this function, it must equal to the point of f1, and it must equal to the limit for x approaches 1 from the right hand side, which is ax plus b. So limit axis and limit is same with the point. So this is the equation we should write when we know that the function is already continuous. Then only we can start calculate. And then you can see this point, f1. f1 point is follow x, means this one is definitely equal to each other. So we just make sure this also equal to the function at the right hand side here. So here you can see limit is same with the point already, because this point is follow your function x. So we calculate here, substitute our limit x equals to 1, we get 1. And then this one, substitute your x equals to 1, we get a plus b. So a plus b, we get the first simultaneous equation. Then we move to the second point here. We can see x equals to 4. Left hand side is different function, right hand side is different function. The point is follow the negative 2x here. As we know, they are continuous. So our equation is supposed to write limit for x approaches 4 from the left hand side, function ax plus b must be equals to the point 4, coordinate 4, and must be equal to the limit x approaches 4 from the right hand side, function which is negative 2x. And we observe here the point is follow negative, so means the point and the right hand side function, they are definitely equal to each other. We just want to make sure our calculation for this left hand side also equal to this part. So substitute our x equals to 4. Substitute our limit x equals to 4 here. And we get this one second simultaneous equation. We solve this simultaneous equation. We have b. Therefore, we do elimination method. We take number 2 minus number 1. So 4 minus a, 3a. b minus b eliminated. Then this one will give us negative 9. A is negative 3. Then we substitute into either one equation, either 1 or 2. So I pick equation 1 to find out the b value. So plus 3, we get 4. Therefore, we have a equals to negative 3, b equals to 4.